manufacturer in the U.S. Sable, Idaho, that's where we do all of our manufacturing. In fact, that's our factory right there. It says 140 employees. Right now we're closer to about 170. But, relatively small family-owned business, and we do one thing, and that is basically just encoders. This slide right here is basically saying all the things that we do in-house. Basically, we just do everything in-house, so I'm not going to read through the whole list. But, we populate our own PCBs, we have our own machine shop, so we're building everything to order. I don't know how many of you have actually worked very closely with our products, but those part numbers get really, really long, and that's because you have to specify mounting, cable, output type, resolution, all these kind of things, and that's all going to go into a different product number, or part number. So, that's the reason that we do build to order, is because we couldn't just stock everything that we can possibly offer. That being said, right now our lead times to build these things for a standard part is 6 to 10 days. That we can actually ship something out the door. And if you ever need something sooner, I know that you guys do a lot more systems integration, custom projects, so I don't know how often you need something last minute or if you need to do any kind of repair, but if you do ever need something last minute, we can ship out in a day or two on almost all standard products as well, so we can expedite. Here's a little bit about, just our quality. We are ISO registered, but we also have a 3-year warranty on all of our products. So, we really believe in the quality of our stuff. I've very rarely seen something actually end up coming under warranty, someone having to return something, just because, we take a lot of pride in the products that we build. This is, like I said, this is just talking about our shipping times. And we also offer full after-sales support. So obviously, you guys are working with IAS, so a lot of your questions and things are probably going to end up going through them. But whenever you need to, assistance with anything, we have a full repair shop, as well as a full technical support team, if you ever need that. I'll go through a little bit of the different types, and then I can get into some of the newer products. I'll start here. So basic principles encoders are used to measure, position, velocity, angle, and it says flow. That's going to be a little bit more rare. But basically, you're going to mount it onto something like a motor shaft. It'll be able to tell you how quickly that motor is turning, or exactly how many degrees it is turned. Same with distance. It's something like a conveyor belt. You would measure the speed or distance that conveyor belt is moved, or angle. So in larger projects, something like a crane, a large construction vehicle, you're going to want to know exactly the position of that cab on the vehicle. So an encoder would be used to measure something like that. Basics of how it works. Right here you'll see there's a disc with lines and windows on it. On one side of the disc is a light. On the other side of the disc is a photo receiver. As that disc turns, it'll go through either letting light through or not. Every time that light is let through and received by the photo receiver, it knows that it's turned a certain amount of degrees. You add enough of those, ticks up over time, you'll know exactly how far you've turned, and if you know how long it's taken for those ticks to come in, you know how quickly you're turning. And so the first type of encoder is going to be your incremental encoders. These are going to have a uniform pattern all around the disk. And so these are going to be the most common ones that you'll see out in the field as well. They're going to be lower cost as well because they are fairly simple. The downsides of these, however, is that you're not going to be able to tell the direction inherently in some incremental encoders because it sees a tick. It doesn't know if it was going clockwise or counterclockwise. This is solved with a second set of lines underneath, slightly offset, so you'll know if I get the outer ring first, I'm going clockwise. If I'm getting the inner ring first, I'm going counterclockwise. And it can accumulate errors in a high vibrational environment. So you can imagine that the disk is vibrating back and forth. All that the encoder sees is that it's getting a pulse and then not a pulse. It thinks it's turning when it's actually not. So those are some of the factors you're going to want to consider when using an incremental encoder. But generally speaking, these are going to have the fastest response time just because it is a photoreceiver receiving a light and sending out an electrical pulse. There's no computation done by the encoder itself. And then the other type of encoder is going to be an absolute encoder. So unlike the uniform pattern of an incremental encoder around the disk, this is going to have a different pattern of lines and breaks all around the encoder, so you know when you lose power exactly what position you're at. So you can imagine, let's say the photoreceiver is on this section right here. An incremental, you would lose power and you would lose your position because the whole disk looks the same, whereas here, everything looks different, so you're going to know exactly the angle that you left off at. And then you could take, a simplified version like this and then expand it out to something like this, which is more what, an actual encoder would look like. Getting into mechanical packages, and these I can pass around. The first one is going to be encoders with a shaft, so something like one of these. Basically, you're going to use these in your more robust applications. They're able to have larger bearings, so they're able to self-align. Because of that, though, they're also going to tend to be more expensive, but be able to withstand higher vibration. Here's an example of one that we have. If you want to pass that around. And then another type is going to be the blind or hollow bore encoders. I can pass one of these around too. This is a through bore rather than a hollow bore, which would just have a back to it. These would mount directly to a motor shaft. So if you are, a little bit tighter for space, if you don't have the capability of actually pairing two shafts together, you would use something like this. Because it doesn't have that mounting plate on it, it's going to be a little bit less robust when it comes to vibration, shock, things like that. Some of the encoders we do are also programmable. Here you can also see one of our wheeled encoders. So these are very, very common in conveyance type applications, also in any kind of extrusion type application where you're measuring length. But these programmable encoders, I have one of them right here. Essentially, you can change the resolution to whatever you want. These are going to be great for any kind of rapid prototyping. You're not sure going into a project exactly what resolution you need. You could test out on this specific encoder anything from 1 to 100,000 pulses per revolution, just on the fly. And then once you dial it in, you can then order, whatever the actual resolution is that you need. And so I have a couple pictures in applications with these encoders. Here's one, for example, one of the blind hollow bore. So the motor shaft is going into the encoder. And so what I want to draw attention to here is the flexible mount, which is not actually bolted down, which is how it is meant to be installed. If you were to actually bolt it down, then the vibration of the motor would be transferred into the encoder itself, which would wear on the bearings, which, as the only real moving part of the encoder, the bearings would be the earliest point of failure. So this is here just to keep it from rotating along with the motor shaft. And then, here's an example of a wheeled encoder rolling along a belt, just measuring that distance. A lot of applications you either don't have access to the actual motor shaft, or in a case like this with a conveyor belt, you don't want any slippage. A lot of times when you're measuring something, you'll measure the motor, you'll do your math, any kind of a gear ratio or something that'll eventually get you to the end product and exactly how much that is moving. But let's say the belt slips, that's not being captured by any kind of motor movement. So you are going to want to actually put it directly onto what you're measuring, something like the wheel on a conveyor belt. And then one more type of mechanical package we have are bearingless encoders. These are definitely less common. The one on top is our model 121. The thing with these is because they don't have bearings, they don't have that mechanical point of failure, and they also don't have the friction of those bearings. So for incredibly high-speed applications, you're often going to want to use a bearingless encoder. They are definitely more work to install because you have to set that gap of air where the bearings would be yourself. They can be prone to problems if there is any slight misalignments. And then also down there we have our magnetic encoder, which is actually very robust because, again, there are no moving parts. the way it works is that there's this magnet that's mounted to a shaft, this little orange magnet right here, and then there's a divot in the magnetic encoder with its magnetic poles around it. So as that magnet turns, it's capturing that rotation up to 1,024 pulses per revolution. Here's a wheel encoder. I talked about that already, but here's an image of it rolling along an elevator shaft. So that's another example of when the encoders that we have, you can see these would not fit around an elevator shaft. So capturing the motion that way is the best way to actually capture the motion. And then here's just a larger version, but a similar idea, just a larger, more metal-housed TR3 dual-wheeled encoder. Another picture of a couple of our small wheeled encoders rolling along, pick-and-place kind of applications along the conveyor belt. And so here is our draw wire encoder. So this is good for linear measurements, something like CNC tables, something like that. Also any kind of like extending boom arm on a crane. You'd be able to measure any kind of linear motion. The way it works is you have the draw wire here connected to a drum, and then the drum is then going to the shaft of one of our cube encoders. Do you guys have any questions so far? I feel like I'm running through this a little bit quick.
What's the longevity on one of those compared to just the standard rotaries?
The longevity on this is going to be not quite as high, especially if it is in any kind of a harsh environment. The string there, it's strong, but it's also fairly brittle. It's not very flexible, and that's because, especially as you're extending over a horizontal distance, there's going to be some droop there. Mm-hmm. So in order to alleviate that, you keep it pretty a brittle cable. The problem is that once that cable, if anything does happen to it, if it does snap, if it does, get released and just shoot back like a tape measure, it's going to fall off the drum, and we can't repair that at that point. But yeah, for controlled environments, especially in any kind of like vertical extension, it's going to be pretty robust. Here's a little bit more in depth about the magnetic encoder. But yeah, as you can see, another thing I didn't mention is it is IP69K rated. These are very small. They're only about the width of a quarter. I should have one. I can pass it around a little bit later. But yeah, great for certain applications. Anything that's going to be around water, anything high pressure washdown. If you can, use 1,024 pulses per revolution. These are great. They're also very affordable. The encoder itself is only about $40. Once you get all the mounting and everything else, it only goes up to about $80. And then, so next is one of our newest products. This is our LP1 non-contact encoder. So I'll pass it around, but as you can see, it's only about the size of a matchbox. And so the way it works is it has these two lasers underneath that are taking an image of whatever it is that it's measuring, and it's used to measure the speed of a flat surface. So here, there's the underside of a turf grass mat. Let's see if I can play it. But yeah, encoder mounted right there, just measuring the velocity of, like I said, in this case, a turf grass mat. Usually it'll be in a lot of conveyance applications, extrusion applications. Oftentimes in place of the wheeled encoder. Very similar because it does do linear measurement. A little bit more niche, definitely a bit more expensive. But if you need to fit something in a small space, if you can't interact with what it is that you're measuring, think of in a printing application something like a very fine film, something that you don't want a spring-loaded wheel bearing down on. You could use something like this to capture that speed. So there's some of my contact info. I unfortunately committed the worst sin of a salesperson. I ran out of business cards and I ordered more and they did not come in yet. So of course though, first point of contact is going to be these guys over at IAS, so they know how to get in touch with me as well. Yeah, and then any customer service questions, you can also just call the factory in Idaho. One thing about Encoder Products that we also take a lot of pride in is if you call our factory, you are going to be speaking to a real human being in less than 60 seconds. no automated anything. We're good at picking up the phone and answering emails. So this is our newest partnership with a German company called TWK. And so what they specialize in is safety rated encoders. I don't know how many of your projects end up having safety ratings as a part of them, but this was definitely something that we didn't have in our catalog until we started working with TWK. So yeah, up to SIL 2 PLD. Actually the previous shaft encoder I passed around was one of them. And then this is another one here with an actual cutout, so you can see all the cool mechanical gears in there. I don't know how familiar you are with single turn versus multi-turn encoders, but basically in absolute encoders, like the one I showed you earlier, you have your entire position for every degree around the disk. What that doesn't tell you is how many turns you've actually done. So, like I said before, you need to know the position of something like a crane. You really only need, up to 360 degrees to know exactly your position there, because you're never going to go more than one full circle. Whereas something like a CNC machine, where you need to know the position, but you might have to turn the encoder multiple times to get all the way to the end, you're going to want to track how many turns you've done in addition to where you currently are in the rotation. With safety encoders, the way that something that they have to do there is keep track of that information mechanically, rather than having any kind of electrical point of failure. In most absolute encoders, they track that multi-turn resolution with just a register that's basically keeping track of these things, versus in something like a safety encoder, just multiple gears. So they know by what that final gear is at, how many full rotations the encoder's done. I think I have more information on safety encoders here, but yeah, here's a breakdown. I can email these slides to you guys if you're interested, but just a breakdown of what it takes to define something as SIL 2 PLD, SIL 3 PLE, something like that. And then these are going to be some of the applications that you might work in that are going to require safety. Generally speaking, I assume your customers are going to request safety if they need it. But yeah, anything, collaborative robots, anything that's going to be around people, can be dangerous to people. You're going to want very likely a safety encoder, as well as safety products of other kinds, safety controllers, safety relays, in those projects.
How does a safety encoder differ from a standard multi-turn? Does it have redundant channels, or?
Yep. Yeah. So I'm glad you asked. So. Basically, a lot of times you'll have, even some non-safety encoders will have redundant channels without being safety rated, still have that either multiple output or sometimes even multiple types of technology. So we've sold encoders in the past that are basically a magnetic encoder mounted to an optical encoder that share a single shaft. And so what that's going to do is, let's say you have a failure that's related to the type of technology itself, you'll still have that separate type of technology. So, I don't know, dust fills the encoder, and all of a sudden that disk is not giving you the reading you want. That's not going to affect the magnetic encoder. That's just going off the magnetic fields. The way that safety encoders work is they also have two redundant channels, but instead of having those two channels checked by the PLC and comparing them, that check is done within the encoder itself. So, a flag is thrown out before that signal is even given to the PLC. So it's just going to be a faster response time in case there are any issues like that. And especially if there is any kind of noise in the line, the signal for a flag is going to be thrown up versus, the PLC checking for these things and having that noise be the issue itself. And yeah, here's just some more advantages of the SIL 2 and SIL 3 encoders. The wiring is simpler because again, it's not two redundant outputs that each require their own cabling, their own wiring. It's all going to be going through a single cable. Fast response time, like I said, because the check is done within the encoder itself. Very comprehensive internal monitoring I mentioned. And lower system costs. Despite the perception, safety encoders often cost less than the redundant solution because they only require a single encoder.